Okay, a function has a derivative given by this. Let's read it very carefully because they actually did not give us the function. They gave us the derivative. So sometimes we get in a habit of taking a derivative and we already have it. So find all critical values. Now, let's be really careful about this. Critical values are not necessarily critical points, and we don't have to get caught up in the vocabulary on this too much, but these are going to be x values of f of x. And classify them as relative minimum, maximum, or neither, and justify your answers. Okay, well, so here's the deal. We are going to be looking for everywhere that this derivative, first of all, equals 0, or everywhere this derivative doesn't exist. Okay, well, this derivative is going to exist. If you graph this, it's a polynomial. You'd have some little lovely flowing up and down across the x-axis a few times sort of thing, all right? It's going to exist everywhere. You don't have jagged, no absolute value-ish type stuff, okay? What I like to do, though, is grab this color pen and draw a number line. You've seen this before. I know you have. And we have places where the derivative equals 0 at, don't think too hard, -5. If you set this whole thing equal to 0, set each factor equal to 0. -5, -1, and +4. And again, we can do a lot of this in our head, and we've done this in our head on other problems. So what I want to do is decide if this are maximum, minimum, neither, I don't know. And when I say relative, it may not be the highest or the lowest, but it would be the highest or lowest in its own little area, okay? So what we're going to do is determine if the derivatives are positive or negative in each of these intervals. Again, you've seen this before. And I'm going to do a lot of this in my head with a green pen, which means I'm going to draw in my brain with a green pen. And also, number line not drawn to scale. That's 5 units wide, and that one's 4. And so it's off, but whatever. Okay, I'm going to pick a number in this interval, -6, for example. -6 would give me, well, a negative, and a negative, and a negative squared, which would give me a positive, and a negative. So I have a negative, negative, positive, negative. So what I'm really going to have here is, and this is the way it can happen in your head, a derivative that is negative. I don't know what the actual number is. I just care that it's negative. All right. Let's pick a number in this interval, like -2, for example. I'm going to have a negative, and notice I'm pointing at that coefficient, so negative. Plug in a -2, gives me a positive. I put a -1. We'll go with it. -2 goes here, becomes squared. That one's always going to be positive because it's squared. We're not playing with imaginary numbers. And a negative goes here. It's going to give me another negative. I have a negative, positive, positive, negative. So we're going to have a positive. All right. Well, I'm on to something here. Here's the deal. I actually know one of the answers already. I know what happens at -5. I know my function is decreasing on the interval from -infinity to -5, and then increasing. So if I graphed it using old scrap paper, then at -5, I have no idea exactly what it looks like, but I do know that it would be decreasing and then increasing. I'm going to have a minimum at -5. So this one right here is going to be a relative minimum. Maybe it's an absolute, but we'll just go with relative. So we're going to have a relative min. Relative, that's an E, there we go. Relative minimum at x equals -5. Okay, let's keep driving this train, see what happens. Let's plug in a 0, that's going to be an easy one. So negative from the negative there. Plug in a 0 there, I get a positive. Plug in a 0 there, you're going to get a positive, always a positive in that part, and a negative there, and you're going to get overall where the derivative is positive. So you have transitioned, so to speak, from a positive to a positive, meaning your function was increasing and then it kept increasing, which means you've not reached a maximum or a minimum. So this one is neither. So we're going to say that we have neither at, and I spelled at this time rather than putting the at symbol, but it doesn't matter. X equals -1. And then let's do this last part right here. Now you're probably like, well, if we got a minimum and a neither, we're going to have a maximum. Maybe not. Maybe this one continues to increase and it would also be neither, right? Or, if this was decreasing and that one was increasing, we'd have another minimum. So we can't just assume we have one of each, right? That's just not fair to say. So let's figure it out. Negative comes from the front. Plug in a 5. 5 plus 5 is positive. 5 plus 1 squared, that's positive. And 5 minus 4 is positive. And we're going to have lots of positives except for that negative in the front. That gives me, there we go, negative. We have transitioned from positive derivative to negative derivative, which means we've transitioned from increasing to decreasing. When you go from increasing to decreasing, you have a maximum. Let me prove it to you. When I go from increasing to decreasing, we have a maximum. There it is. So we do indeed have a relative max. Relative max at x equals 4. And that's it.